everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem: solve y double dash plus 4y dash plus 4y equals to 4 cos x plus 3 sin x. We are given initial conditions: y at 0 equals to 0, y dash at 0 equals to 0. Solution: firstly, let's find the order and degree of the given differential equation. Given differential equation, y double dash plus 4y dash plus 4y equals to 4 cos x plus 3 sin x. Right? We can write it as d square y by dx square plus 4 into dy by dx plus 4y equals to 4 cos x plus 3 sin x. Identify the highest derivative. Here d square y by dx square is the highest derivative, so our order will be 2. And the highest power of the highest derivative is the degree. Degree is 1, right? Now we'll write the equation in operator form. We know that differential operator d is d by dx. Then d square will be d square by dx square. Now we can write d square y by dx square as d square y plus 4 into dy by dx as dy plus 4y equals to 4 cos x plus 3 sin x. Right? Now let's take y common from all the three terms of LHS. We'll get d square plus 4d plus 4 into y equals to 4 cos x plus 3 sin x. Right? Which is in operator form. F of d into y equals to q, where f of d equals to d square plus 4d plus 4 and q is 4 cos x plus 3 sin x. Right? Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function and yp is a particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. Simply by taking RHS to 0, we'll get f of d into y equals to some 0, which is a homogeneous equation to the given non-homogeneous equation. And we'll find yp using 1 by f of d into q. Now let's find complementary function firstly using the auxiliary equation. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square plus 4d plus 4, right? Let's replace differential operator d by m, then we'll get f of m equals to m square plus 4m plus 4. Then our auxiliary equation becomes m square plus 4m plus 4 equals to 0, right? We can again split this 4m as 2m plus 2m, right? Now we can take m common from the first two times and take 2 common from the next two terms. You notice we are having m plus 2 in both the terms, right? So let's take m plus 2 common, then you'll get m plus 2 into m plus 2 equals to 0. Equate each factor to 0. From 1 m plus 2 we'll get m equals to minus 2. Right? Then m equals to minus 2 are the roots of the auxiliary equation, or This of a square plus 2ab plus b square form, a plus b whole square, right? We can write 4m as 2 into 2 into m, and this 4 as 2 square, which is in a square plus b square plus a into b, 2 into a into b, right? Better. Expansion of m plus 2 whole square, which means you're having m plus 2 into m plus 2. If you equate each factor to 0, we'll get m equals to minus 2, minus 2. So minus 2 is repeated root or equal root, we can say. Therefore, m equals to minus 2, minus 2 are the roots of our auxiliary equation, right? Which are equal. We know that if two roots say m1 equals to m2, or if two roots m1, m2 are equal, then we can write complementary function as we are having two equal roots, right? So under brackets we'll get two constants or two terms, c1 plus c2x into e power that equal root into x, right? Then our complementary function will be for m equals to minus 2, minus 2, y is equals to c1 plus c2x into e power minus 2x, right? Equal root into x. Now let's find particular integral. We can find particular integral using 1 by f of d into q, which is equals to 1 by f of d, d square plus 4d plus 4 into q is 4 cos x plus 3 sin x. Again, you can write this as 1 by f of d into 4 cos x plus 1 by f of d plus 3 sin x. Now we can write yp as constant into 1 by f of d, d square plus 4d plus 4 into cos x plus constant 3 into 1 by f of d, d square plus 4d plus 4 into sin x, right? Or we can name 1 by f of d into cos x as yp1 for our convenience, and 1 by f of d into sin x as yp2, and we can find yp1 and yp2 separately, right? Firstly, let's find yp1. We have 1 by f of d into cos x. So this is of 1 by f of d into cos ax formula. Form. Then for a equals to 1, we need to find d square, which is given by minus a square. Then for a equals to 1, we'll get minus 1 square equals to minus 1, right? Now, we'll replace d square by minus 1 and see what we are going to get in the denominator. Always the denominator must be non-zero. If the denominator becomes 0, the total term becomes 1 by 0 into cos x. Since 1 by 0 is undefined, then the total term becomes undefined, right? So, we should get denominator non-zero. Okay, so let's see what happens if we replace d square by minus 1 in the denominator. take the denominator part and replace my d square by minus 1. Minus 1 plus 4 is 3 plus 4d, which is non-zero, right? So we can replace d square by minus a square. That is minus 1 square equals to minus 1. Then we'll get 1 by minus 1 plus 4d plus 4 into cos x is equals to 1 by minus 1 plus 4 is 3 plus 4d into cos x, right? Now just write this fraction as it is. Here in the denominator you're having plus, right? Just change it as minus, then you'll get 3 minus 4d. Now multiply and divide 3 minus 4d to this fraction, okay, into cos x. Then yp1 becomes 1 into 3 minus 4d is 3 minus 4d by 3 plus 4d into 3 minus 4d into cos x. This becomes 3 minus 4d by, the denominator we are having two terms which is of a plus b into a minus b form, so we can write it as a square minus b square into cos x is equals to 3 minus 4d by 3 square is 9 minus 4d whole square, 4 square 16 into d square into cos x. Again d square appears in the denominator, so we'll check by replacing d square by minus 1. We'll get 9 plus 16 which is 25, non-zero. So we can replace d square by minus 1 here. This becomes 9 minus 16 into minus 1 into cos x. Right? Which is equals to 3 minus 4d by 9 minus into minus plus 16 into cos x is equals to 3 minus 4d by 25 into cos x. Again you can write this as 1 by 25 into 3 cos x minus 4 into d cos x. We know that d is a differential operator. This becomes 1 by 25 into 3 cos x minus 4 into, replace d by dx. Okay, we'll replace differential operator d by dx into cos x. Now we need to find derivative of cos x. 4 into derivative of cos x is minus sin x equals to 1 by 25 into 3 cos x minus into minus plus 4 sin x. Now let's find yp2. One by f of d into sin x. So this is of 1 by f of d into sin ax form. For a equals to 1, we'll find d square which is given by minus a square which is equals to minus 1 square equals to minus 1. Now Let's replace d square by minus 1 and see what happens in the denominator. We have to get denominator non-zero. Okay. I mean, the denominator must be non-zero. If the denominator becomes 0, we'll get the total term undefined. The total term becomes undefined if the denominator becomes 0 by replacing d square. So I'm taking the denominator part and let's replace d square by minus 1. Minus 1 plus 4 is 3 plus 4d, which is non-zero, right? So let's replace. Replace d square by minus 1 square equals to minus 1 equals to 1 by minus 1 plus 4d plus 4 into sine x equals to 1 by minus 1 plus 4 is 3 plus 4d into sine x. Now we can write this as 1 by 3 plus 4d. In the denominator of the fraction you're having 3 plus 4d, right? Change this plus to minus, then we'll get 3 minus 4d. Now multiply and divide with 3 minus 4d to this fraction into sine x. This becomes 1 into 3 minus 4d is 3 minus 4d by 3 plus 4d into 3 minus 4d into sine x becomes 3 minus 4d by, in the denominator we are having 3 plus 4d into 3 minus 4d, which is of a plus b into a minus b form. We can write it as a square minus b square equals to 3 minus 4d by 3 square is 9 minus 4d whole square is 4 square 16 into d square into sine x. Again d square appears in the denominator. Now take the denominator part and replace d square by minus 1. We'll get 9 plus 16, which is 25 non-zero, right? So we can replace d square by minus 1 in the denominator. Then we'll get 3 minus 4d by 9 minus 16 into minus 1 into sine x, which is equals to 3 minus 4d by 9 minus into minus plus 16 into sine x, which becomes 3 minus 4d by 9 plus 16, 25 into sine x. We can write this as 1 by 25 into 3 sine x minus 4d sine x. We can replace differential operator by d by dx, since d being a differential operator. Now we need to find derivative of sine x with respect to x. We'll get minus 4 into derivative of sine x is cos x. Therefore ypt equals to 1 by 25 into 3 sine x minus 4 cos x. See, it's not necessary to find yp1 and yp2 separately. We can just go with the flow. Okay, in one step you can solve everything. But in order to show you clearly, I'm doing yp1, yp2 separately. Okay. Now, coming to yp. Result obtained from yp1 is 1 by 25 into 3 cos x plus 4 sin x plus result obtained from yp2 is 1 by 25 into 3 sin x minus 4 cos x, right? This becomes, just multiply these two terms with 4, then you'll get 1 by 25 into 3 4s are 12 cos x plus 4 4s are 16 sin x plus 1 by 25 into, multiply this through two terms with 3, you'll get 9 sin x minus 3 4s are 12 cos x, right? Now we'll get 1 by 25, take 1 by 25 common, then you'll get 12 cos x plus 16 sin x plus 9 sin x minus 12 cos x plus 12 cos x minus 12 cos x gets cancelled, equals to 1 by 25 into, this becomes 1 by 25 into 16 sin x plus 9 sin x is 25 sin x, right? 25 gets cancelled and you'll get sin x. Therefore yp equals to sin x. Now we are having yc and yp. So we can write the general solution. The general solution is given by y equals to yc plus yp. Then y equals to yc, we have c1 plus c2x into e power minus 2x plus yp sine x, right? Now we need to use the given initial conditions to find the constants c1 and c2. Okay, here c1 and c2 are unknown constants, right? I mean arbitrary constants. So we'll find the values of c1 and c2 using these initial conditions, right? So let's find y dash also. For that we can write y as c1 e power minus 2x plus c2x into e power minus 2x. I'll consider the general solution as equation 1. Okay, plus sin x. Now let's find y dash. Derivative of y is c1 into constant into derivative of e power minus 2x is minus 2 into e power minus 2x plus c2 into derivative of x e power minus 2x is, here to find the derivative of x e power minus 2x with respect to x, I can say we can use uv whole dash formula, which is equals to u dash v plus v dash u, right? Firstly, we'll find derivative of x with respect to x into e power minus 2x plus x into derivative of e power minus 2x, right? Which is equals to derivative of x with respect to x is 1 into e power minus 2x plus x into derivative of e power minus 2x is minus 2 into e power minus 2x, which is equals to e power minus 2x plus into minus minus 2x e power minus 2x, right? So I'm going to write this directly here. Okay, derivative of x into e power minus 2x is e power minus 2x minus 2 into x into e power minus 2x plus derivative of sin x with respect to x is cos x. Now y dash becomes y dash equals to minus 2c1 e power minus 2x plus c2 e power minus 2x plus into minus minus 2c2x e power minus 2x 2c2x e power minus 2x plus cos x, right? Consider it as equation 2. Now let's use the given initial conditions. The first condition we are given y at 0 equals to 0, which is nothing but y equals to 0 at x equals to 0. So we need to consider equation 1, which is in y and x, right? So consider this equation. Now put y equals to 0 and x equals to 0. Just replace x by 0 and y by 0. Okay. 2 into 0 plus sine 0 equals to 0 equals to c1 plus c2 into 0 is 0 into e power minus 2 into 0 is 0 plus sine 0 is 0. Then we will get 0 equals to c1 plus 0 c1 into e power 0 is 1, right, plus 0. Then we'll get c1 equals to, or 0 equals to c1 into c1 into 1 is c1, right? Therefore the value of c1 is 0. Now find the value of the other constant c2 using the initial condition y dash at 0 equals to 0, which means that y dash at x equals to 0 equals to 0, right? That is y dash is 0 when x equals to 0. So now we need to use equation 2. Replace y dash x value 0. Okay, just substitute y dash 0 and x 0. We'll get 0 equals to minus 2c1 into e power minus 2 into 0 plus c2 e power minus 2 into 0 minus 2c2 into 0 into e power minus 2 into 0 plus cos 0. We know that 0 into anything is 0, so this total term becomes 0. Then 0 equals to minus 2c1 into e power minus 2 into 0 is 0 plus c2 e power minus 2 into 0 is 0. This becomes 0, right? Or minus 0 plus cos 0 is 1. Then we'll get 0 equals to minus 2c1 e power 0 is 1 plus c2 into e power 0 is 1 plus 1, right? Now we have 0 equals to minus 2c1 into 1 is minus 2c1 plus c2 into 1 is c2 plus 1. Now we can replace the value of c1. Since c1 equals to 0, then we'll get 0 equals to minus 2 into 0 plus c2 plus 1, which becomes 0 equals to minus 2 into 0 is 0 plus c2 plus 1, right? We'll get c2 plus 1 equals to 0. From this we'll get c2 equals to minus 1. So we got the value of c2. Let's replace c1, c2 values in equation 1 now. Substitute the values of c1 and c2 in 1, right? Then 1 becomes y equals to c1 0 plus c2 minus 1 into x into e power minus 2x plus sin x. Then y equals to 0 plus minus 1 into x is minus x into e power minus 2x plus sin x. Then y equals to minus x e power minus 2x plus sin x is the required solution. So we have seen a problem from higher order linear differential equation in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.